Hello, and today's learning target is I can divide monomials, day 2. So here we are going to look at what happens when we get negative exponents left over. So if we subtract exponents and we still have some that are negative, what do we do? Because we cannot write our answers with negative exponents. So we're going to look at that. We also are going to look at what's called the zero product property. The zero product property, and this is an important property, states that anything, so any number, any variable, anything to the 0 power simply equals 1. And you could type this in your calculator, 5 to the 0 power, you'll get 1. 10 to the 0 power, you will get 1. Give it a try and make sure that you see that. Hopefully, you know how to use the exponent button in your calculator. And if not, we'll discuss that in class. But again, anything to the 0 power equals 1. So let's take a look here what that means. So with this first example, I have a lot of different numbers and variables in a set of parentheses. It's all to the 0 power. So all of that simply just equals 1. All just equals 1. Don't even have to worry about anything else inside those parentheses. It's 1. The answer is 1. But when we get to the second problem here, this is a little bit different, okay? I have x to the 5th times, write this down, x to the 5th times 1, because y to the 0 power is 1, all over x to the 3rd. If I take away 3 x's from the bottom, 3 away from the top, I'm left with 2, or simply remember that 5 minus 3 is 2, and my final answer is x squared. Don't have to do anything with those y values again because y to the 0 power is 1. Okay, let's continue. And now I see, a lot of numbers or in variables all to the 0 power again. That just equals 1. Don't even have to worry what's inside those parentheses. If it's 2 to the 0 power, it's just 1. All right, and last here with this set, this one looks like an example we did right above it, and that d to the 0 power just goes to 1, so I can rewrite that as 1. B to the 4th over b squared. If I take away 2 b's, I'm left with b squared in the numerator. Take away a c, I'm left with 1c in the numerator as well. And I could say c to the 1st power, but I do not need to write that. So b squared c is my final answer. So that is what the zero exponent property states. Again, that every or any number or variable, anything to the 0 power equals 1. All right, now let's look at negative exponents and more about what it means to have a negative exponent. Well, we cannot write our answers with negative exponents, so we must find the inverse, meaning that to make them positive, we will flip the monomial over the fraction bar and change the sign of the exponent. So, with this first example, n to the negative 3rd, if I want to rewrite that to become positive, a positive exponent, I'm simply, if this is over 1, going to flip the fraction. Okay, so I'll have 1 over n cubed. Again, that's the inverse of n to the negative 3rd. Similarly, 1 over b to the negative 2nd, I will flip those and get b squared over 1. I don't necessarily need to write the over 1, so I can erase that. So the inverse of that to make a positive exponent would be b to the positive 2nd. Okay, now we have a little bit more here with this third example. I have a couple different negatives, so n to the negative 5th and r to the negative 2nd. I will flip both of them because they're both negative. So when I flip them across the fraction bar, that's their inverse, which makes them positive. So I get p to the 4th r squared all over n to the 5th. So again, by flipping them, I get the positive value of that exponent, which is what I am looking for. Okay, let's look at a few examples. I'm going to break up this problem into separate components. So I'm going to keep the numbers together, the r variables together, the t variables together, and the u variable in its own group. So when I break this down, I have 5 over negative 20, which I'll look at simplifying, r to the negative 3rd over r squared. I'm multiplying these. I have t to the 4th over t to the 7th. And then I have 1 over u to the negative 5th. Okay, so let's simplify 5 over negative 20. If I take out a 5, that becomes a 1, the 20 becomes a 4. So I really have 1 over negative 4, and it does not matter where I leave that negative sign. I could put it out in front of the fraction, or I could leave it with the 4, could put it in the numerator. I'm just going to leave it where it's at for right now to not have to do too much moving around if I don't have to. Now I have r to the negative third over r squared, so r to the negative third minus 2 gives me r to the negative fifth in the numerator. So I'm going to write, let's make sure that looks like a 5. I'm going to write r to the negative fifth over 1. Okay, and I know I'll eventually have to flip that because I can't have a negative exponent, so I'll worry about that in a moment. Now t to the fourth over t to the seventh, so t to the 4 minus 7 is t to the negative third. Again, I know I'll have to flip that eventually. And then I have 1 over u to the negative fifth, and I'm going to flip that right now because I have nothing else in the numerator, so I want to make that positive. So u to the fifth over 1. And now I'll do a little bit more simplifying. Okay, so I have 1 over negative 4, and then I'm going to flip this r to the negative fifth and bring it on the bottom. So it becomes 1 over r to the positive fifth. And then I'll flip t to the negative third. And then u to the fifth stays on top. So now if I combine everything, right, I have u to the fifth on top. I do not need to write that 1 because it's a silent 1 in front of u to the fifth, and u to the fifth can replace that 1 with, there's already a 1 in front of the u. And then I have negative 4, r to the fifth, t to the third, and that is my final answer. Let's look at the next example. Okay, so again, I'm going to break this up and write 2 over 10 times a to the second over a to the negative third times b to the third over b to the negative first, c to the negative fifth over c to the negative fourth. Okay, so 2 over 10 simplifies to 1 over 5. A to the second minus negative 3, chop chop plus equals a to the fifth in the numerator, so that's over 1. B to the third minus negative 1, chop chop, is equal to b to the fourth in the numerator. And then c to the negative fifth minus negative 4, chop chop, is really c to the negative first in the numerator. So I know there's a couple things I'm going to have to still simplify. Well, one in particular here. The c to the negative first, this will have to flip to the denominator. So I get a to the fifth, b to the fourth. Again, I do not need to write this 1. All over 5c, and that would be my final answer. Okay, let's continue on here. All right, let's break up the numbers and the variables. So 32 over 4, a to the negative eighth over a to the third, b to the third over b to the fifth, and c to the negative fourth over c to the negative second. So 32 over 4 simplifies to 8 over 1. I have a to the negative eighth minus 3, which is a to the negative 11th. So right now, instead of writing that out, I'm just going to, that's really over 1, I'm going to flip that right now. Okay, so I get 1 over a to the 11th. Now I have b to the third minus 5, which is b to the negative second, which over 1 is over 1, so I'm going to flip that to make that positive. Get 1 over b squared. And then c to the negative fourth minus negative 2, chop chop plus, is c to the negative second over 1, but I'm going to flip that to make that positive right now as well, so I don't have to, so I can do a couple steps into 1. I can combine them, right? Make it easier. So now I have 8 times 1 times 1 times 1, which equals 8. A to the 11th b to the second c squared, and again, I don't need to write that 1, and that would be my final answer. And again, too, it's sometimes proper too to write your variables in order of alphabetical. So A listed first, B second, C third. But so doesn't necessarily matter. It's just a good rule to try to remember. Thanks for listening. Have a great day. Bye-bye.